Okay, let's look at this. This is going to be the next quiz, so you have to understand this problem. Okay? Atrazine is a herbicide widely used for corn and is common for groundwater pollutants. Let's see, this is you are growing corn. Okay, so they put herbicides on them to kill insects, to kill worms, to make sure that this corn is growing in a nice way. There is no pollutant, there is nothing that will destroy the life of this corn. But the problem with this herbicide, atrazine, it will go to the groundwater. It will infiltrate the groundwater and then pollute it. Okay. The log KOW of atrazine, this is in tables. So this should be given because every chemical has a log KOW. Look at how much is this. 2.65 is huge. Log KOW means that this will be partitioned from the water to the soil. Right? It will love soil. Okay? Calculate the fraction. Look at this question. Calculate the fraction of total atrazine that will be absorbed into the soil. You need to know the percentage of atrazine in the soil. I would expect it's over 90% because you can see from the KOW, it's huge. So it will be very high absorption, the percentage of, or the fraction of the atrazine in the soil. Given that the soil has 2.5%, this is a fraction of organic carbon. The bulk density, remember, is 1.2 gram per centimeter cube. What is the meaning of this bulk density? It means for every cubic centimeter, which means every cubic centimeter of what? Soil and water, it contains only 1.2 gram of soil particle. Okay? That's the meaning of bulk density from soil mechanics. The porosity of the soil is 0.4. What is the meaning of 0.4? The pores is 0.4. 0.6 is solid. 0.4 is pores, and these pores are filled with water. 0.6 is what? Solid. And of course, we're going to use this correlation. Since we have KOW, we could find log, you could find log KOC from this equation, which is Baker et al. 1997. So we do the log KOC, and we could plug it into the equation. We'll find log KOC is equal to 2.49. So KOC is equal 10 to the power 2.49. KOC is equal now 309 meter cubic per gram. Of course, gram of organic carbon. Now, once we find KD, once we find KOC, let's find KD. KD is equal KOC times FOC. KOC, we have it. Fraction of organic carbon, we have it. Now, KD is 7.73 centimeter cube per gram soil. Okay, for every gram of soil, there is 7.73 centimeter cube. Every centimeter cube of soil has what? 1 gram of organic carbon. Now we're going to assume that it is 1 centimeter cubic soil. Okay? Since he did not tell you that, of course, in groundwater there's a lot. So you're going to do it bare 1 centimeter cubic of soil. From the porosity, he told you it's 0.4, as we mentioned before. 0.4 porosity means 0.6 centimeter cube soil and 0.4 centimeter cube of void space, which is assumed to be filled with water, of course. The void has to have water because it's groundwater now. And now this is for every centimeter cube, 0.6 soil and 0.4 void. And from the bulk density, remember he told you it's 1.25 gram per centimeter cube. If you multiply it by 0.6 soil, you would get that the mass of the soil is 0.75 grams of. So every 1 centimeter cube of soil has 0.75 grams of soil. Now we're going to do mass balance. So total atrazine is equal the concentration of the organic in soil, the atrazine, plus the concentration of the organic in solution, aqueous solution. We'll be doing the same thing. In soil, we multiply mass of the soil times the concentration in soil sorbed. The aqueous atrazine, we multiply the volume times the concentration. Same way we did from the previous example. And now we want to make it as a function of C aqueous, so you have to change this to C aqueous. Mass of the soil, we mentioned here, mass of the soil is 0.75. This is bare centimeter cube. So 0.75 grams. And C sorbed. C sorbed, remember, we have it here that Kd is equal to what? Kd is equal C solid over C water. The concentration of the organic in the solids over the concentration of the organic in the water. So now we want to make it as a function of Cw. So C sorbed or sediment is equal Kd times Cw. Okay, so we have Kd. Kd is 7.73 centimeter cubic per gram times C aqueous. Now we finish from the first soil. Now we come to the water. What was the volume of the water? Remember, the volume of the water, which is the volume of the voids, which is filled with water. It's all underground water. It's 0.4 centimeter cube times C aqueous. So now we have C aqueous and we have C aqueous. We take it as a common factor and we can see total atrazine in every centimeter cube is equal C aqueous 5.8 plus 0.4. You can see that most of the atrazine is in where? Is in soil, while the other atrazine is in the void or in the water. So what was the question? He needs to know what is the question here. What is the fraction of total atrazine that will be absorbed into the soil? Okay, into the soil. You can see this is in the soil. So 5.8 divided by 0.4 plus 5.8 times 100. So this is, let me calculate it. So 0.4 plus 5.8, okay, 5.8 times 100, and that will give you 93.5 or 94%. So if the percentage of atrazine in soil, of course, I would expect X because log KOW is really high, which means that 94% of atrazine in soil and 6% in water. Okay? We'll see you, inshallah, in the next slide.